Okay, so we're going to solve the rational inequality 2x squared plus x minus 1 over x minus 5. We're going to set it greater than or equal to 0. Okay, now I'm going to show you some kind of shortcuts, some quicker things you can do as opposed to the way we were shown in the module to kind of speeden up the process. Okay, because there's a lot of things that we can really cut out when we get to our final answer. But the first thing we need to do is we need to factor everything we can. So we're going to factor the numerator and the denominator if we need to. So let's factor. We're going to have to factor the numerator. And if you factored it correctly, it should come out to 2x minus 1 and then x plus 1. And then the bottom doesn't need to be factored. It's already good. So it's greater than or equal to 0. So now it's factored. Okay. Now what we do next is we're going to take each factor on the left side of our inequality. We're going to take each factor, and we would set it equal to 0 and solve. Now I'm going to skip that because I'm assuming you know how to do that. Okay, and I want to really get to the important stuff here. But if you took that first factor, 2x minus 1, and set it equal to 0, when you solve that, x should equal 1/2. Okay, so that's one of our points of division. All right. Our second factor, x plus 1, if we solve that one, we'll get x equals -1. So that's our second point of division. And then our factor on the bottom of x minus 5, well, if we solve that, set it equal to 0, solve that one, we're going to get x equals 5. So we have our 3 points of division, which means we have 4 intervals to test. Okay? Now I'm going to show you a little bit differently here. What I'm going to do is I'm going to set up a number line to help us kind of visualize our points of division and our separate intervals. Okay? So you picture our lowest point of division is -1. Then we have 1/2. And then we have a 5. Okay? So that means, like I said, we have 4 intervals. We need to pick a test point, and we're going to plug it into the factored expression. Basically, if you look at this second step right here, okay, we're going to plug it in. Now, what I'm going to show you here is, remember, the important thing is we need to figure out the sign of the inequality to see if it agrees for each interval. It doesn't matter what the actual value comes out when we plug in our test points. So that's the big thing I wanted to show you in this video. So when we pick a test point, first of all, we need to pick something less than -1. I'm going to pick -2. Okay. You could pick anything you want less than -1. I'm just going to pick something convenient. Okay. So I'm going to pick -2. All right. So that means when we plug into this factored form, okay, we're going to get 2 times -2 minus 1, which is -1. But the big thing is, I'm just going to put a sign here that shows that it comes out negative, okay, for that factor. Then when I plug in -2 into the factor x plus 1, we're going to get -2 plus 1. That means we get -1. So we get another negative, okay? And then when we plug in -2 into the bottom factor, into that x minus 5, well, that comes out to a -7. But again, the important thing is it comes out negative. Okay? Now, the important thing, again, it doesn't matter what the value comes out to. I'm just interested in the sign, and that's going to tell us whether it's positive or negative on that interval. Well, if we remember the rules of multiplication and division, when you multiply 2 numbers up top, you're multiplying 2 negatives, you get a positive number. Then you take that positive, you divide by a negative, well, that means my answer has to come out negative. Okay? I don't care what the number is. Again, the important thing is just the sign. So I know that everything is negative. Everything is less than 0 on the interval for any x value up till -1. Anything less than -1. Okay? Now I'm going to use that same concept for every other interval. Okay? So now what I'm going to do, just erase what I had previously. I'm going to pick something between -1 and 1/2. And I have the advantage here, and if you could ever pick 0, it's always a good value to pick. So I'm going to take 0, and again, plug it into the factored form, alright, just like I did before. And again, I'm just interested in the signs. I don't really care what the actual value is. So when we plug in 0 into 2x minus 1, well, when you plug it in, you get -1. So that first factor is a negative. And then when I plug into the x plus 1, that comes out to a +1. Again, the important thing is it comes out positive. Right? Then on the bottom, when you do 0 minus 5, you get negative 5. Well, that's a negative. Okay? Well, again, thinking of just simple rules of multiplication and division, negative times a positive is a negative up top. So then that negative needs to be divided by a negative. We actually end up with a positive value. Okay? And it doesn't matter what the test point is, anything between negative 1 and 1/2, had we plugged it in, would have come out positive, and that's the important thing we're looking for. So we know it's positive on the interval from negative 1 through 1/2. Right? Okay. So next, let's go to the next interval, and we're going to pick something between 1/2 and 5. I'm going to pick the value x equals 1. And again, it doesn't matter as long as it's something between 1/2 and 5. Okay? So now, when I plug in 1 into that 2x minus 1 factor, we get a positive 1, so I know it's positive. When I plug in 1 into the second factor, 1 plus 1 is 2, so again, important thing is it's positive. And then 1 minus 5 in the denominator gives us a negative 4, so gives us a negative. Okay? And then we look at it, well, we've got two positives on top. When you multiply them, it's still a positive number. And then a positive divided by a negative number, we know from the rules of division, gives us a negative number. Okay? So we know that we are negative, we are less than 0, negative, from the interval of 1/2 to 5. Okay? Now lastly, we need to pick something greater than 5. I'm just going to pick 6, but again, it's up to you. Okay? Alright, so that means we're going to take 6, and when we plug it into each factor there, so it's going to be 2 times 6 minus 1. Okay, you know it's 11, but the important thing is, again, it comes out positive. Okay? And then 6 plus 1, the second factor there gives us positive 7, but again, it's positive. And then on the bottom we'll have 6 minus 5, which will give us a positive 1, but again, the important thing is it's positive. So we have all positive numbers, positive times a positive up top gives us positive, and then when we divide by another positive, well, we're still positive. Okay? So we know on the interval from 5, or anything bigger than 5, we know that anything we would have picked would have come out positive. So that means we're greater than 0 in that interval. Okay? So now to determine which intervals will be in our solution set, we go back to our inequality, and if you notice our inequality here, I'll circle it in red, is greater than or equal to. Okay? So that means, again, the big thing here is the greater than. Well, I need to pick the intervals that came out positive. Okay? So that means when you look at it, well, one of the intervals that came out positive was the one between negative 1 and 1/2. Okay? So that means negative 1. And because we had the equal to part of the inequality, all right, we can include the endpoints in this. So it's going to be negative 1 is less than or equal to x, which is less than or equal to 1/2. So we include those endpoints. That's one of our intervals. So x could be anything from negative 1 to 1/2, including those values. And then the other interval that came out positive was the one where we had the x values greater than 5. Now it's important to note that because 5 came from a factor in the denominator, well, we can't have 5. Okay? So we're not going to include 5 in this actual solution set. All right? So that means we're also going to include all the values strictly greater than 5. Okay? Like I said, because it's a factor that came from the denominator, well, the denominator can never be 0. That means x cannot be 5, so we're not going to include that. So it's going to be x is strictly greater than 5. All right? So those are your solutions. So I wanted to show you that just a little bit different way, maybe a little bit quicker, just to show you that really the important thing are the signs of each interval, and that'll help you get your answer.